So the test cross between the heterozygous and the uh, homozygous recessive, you expect it to be 1-to-1 because you expect these two to be the outcome of the haploids, right? But crossing over does occur, and since the longer the distance of two alleles mean crossing over happens more frequently, leads to population having a tendency to have a particular genotype. And so that's what we're trying to find out, the relative distance between the alleles and gene mapping, right? Let's start with M and D. So essentially what you're doing is changing only one thing. You're changing M in relation to D, so M and D. This is supposed to be P. I guess I'm dyslexic. Lol. Alright, let's see. Let's see if we could make that into P. Alright, good enough. So yeah, you just write that down, get the frequency, and then you do the reciprocal of that one. So instead of big M, big D, small d, and then get the number of individuals, you get 62. Well, double crossing does occur sometimes, so there's that, right? These two things that you're trying to find, but double crossing happens, so not only does the M change, but the P also changes. So for that, you just change these up a little bit, and you get the double crossing. You get the two genotypes that are reciprocal to each other, and then find the number of individuals. And then after finding the number of individuals with those genotype, you find the sum. After finding the sum, you divide it by the total, which is 1000, and that should be your frequency. For D and P, you're changing P in relation to D, and if you write down the genotype, you can get you can find the individuals with that genotype, and for that you find 21 and 23. Double crossing does occur, so you have to, so M sometimes also changes. So in this case, big M changes to small m2, and small m changes to big M. And if you find the number of individuals with those characteristics, 4 and 2, find the total, divide by the number of the sum. Yeah, find the total, and then after finding the total, divide by the, after finding, shoot, I can't talk, I'm tired. Okay, so after finding out the sum, divided by the total number of individuals in the test. Alright, so I didn't write M and P, because if you look, M and P changes, but in this case M and P also changes, but in a different way. So in this one, M changes, and this other one, P changes, right? So you add all these two up, right, to find the total. Alright, keep that in mind. But crossing over does occur in both of these two cases. So not only do you have to find the total between these two, but you have to add the double crossing of this and double crossing of that. So you have to get the total of this, get the total of that, add them two together. Um, After finding the sum, divide it by the total of 1000, and you should get the frequency of M and P.